is going to be, okay, you submit your email, your assignment by email, and then you put your name on your assignment, so I will see it. Okay, now, so what we are going to do, we talk about that these functions would be mostly would be defined on the angles. Okay, we talk about trigonometric function, not dealing with the distance, dealing the kind of measurements of the angles. So what we are going to do tonight, we are going to introduce angles that we are going to use. You see, in order to read the trigonometric function, there are different ways to introduce these functions. The easiest one, there is one that we are going to use geometry, if you like. We call it right triangle version. That's very easy and quick to get this type of function first. Then we are going to extend it. When you are going to be in right triangle, it's very a special one. Then we extend it quickly to the type that we are interested in calculus. And if you want to take calculus 1 and 2, especially in calculus 2, mostly we're using that right triangle version, okay, the one that we're going to discuss today. But let's introduce, maybe you don't know what I'm talking about. Let's introduce the topics first, and then we get to that one, okay? So we are going to have a section 1.1, and we talk about angles, our tools, okay? What is going to be, okay, angles that we are going to use in this course. Okay, in order to introduce an angle, okay, 30 degrees, 40 degrees, 50 degrees. So what we're going to do, we're going to pick a kind of the origin over here. It's going to be the origin over here. Then we get this is like the x-axis, if you like. This is going to be the x-axis, okay? We start from here, and then we move here. We move as much as we need, 30 degrees, 40 degrees, etc. So we move and we stop here. Okay, so this is going to be, okay, so if you move in this direction, the amount that you got over here is going to be an angle. This is going to be angle, for example, angle theta. Okay, so this side that you start with, we call it the initial side. This expression is going to be important for us. Okay, this is going to be the starting point. So this is going to be initial. Okay, that's going to be initial side that you start with. And in this direction, you go up as much as you need. So we get to the end. When we get to the end, this is going to be called terminal side. Okay, so that's going to be, this is going to be terminal. Okay, this is going to be terminal side. So the starting point is going to be initial side, then you end up with the terminal sides. Whatever you have in between, that give you the angle theta. Okay, in this direction that we talk about it, you see this direction is going to be kind of counterclockwise. This direction considered to be positive. Okay, so that's going to be positive angle. So this direction give you positive angle. But we are not going to stay, if you want to stay with the positive angles only, you are going to be in triangle all the time. But we are going to use this type of idea for calculus. So we are going to also introduce the negative angles. If you want to get a negative angle, you have to change the direction. Okay, so that's going to be positive angle. So if you want to check something which is going to be negative angles, so this is going to be your starting point. Okay, this is going to be a starting point. Okay, so what you do is the direction would be different. So you go in this direction. Okay, you go in this direction. Okay, in this direction, and then you are going to have an angle here. So this would be a negative angle theta. Okay, so if the direction is going to be counterclockwise, it's going to be representing a positive angle. But if you change the direction, this would be negative angles. So this part, again, this is going to be initial side. Okay, so this is going to be initial. Okay, that's going to be initial side, the starting point. And then you go in this direction, and that end up with the terminal. Okay, that's going to be terminal side. So that would be a representation for the for the negative angle. So this is going to be negative angle. So that will give us the opportunity to introduce positive angles or the negative angles. So if you have, for example, this is going to be negative 30 degrees. This is going to be positive 30 degrees. We usually say 30 degrees, but that would be represent the negative part. Okay, so it's going to be, so there's going to be this space, if you like, to portion of the plane here. So we have the initial side, you start with the initial side and you go as much as you have. Okay, you stop. So this space is going to be your angle, the positive one or the negative one. Okay, any question? So that is the definition of the angle. So the question is going to be how we're going to measure the angles. We are going to have two famous measurements for the angles. And one of them is going to be, the famous one is degrees, and the other one is going to be radian. But in this book, they talk about the second one in chapter 3. So I stay with your book. So I'm going to define just degree only. Okay, so that's the definition of the angles. Now, what is going to be the definition of the unit of the angles? Okay, angle unit. So what is going to be angle unit? Angle unit is going to be degree. So or degree. Okay, what's going to be degree measure? Degree measure. I'm going to, now the distance, you can measure the distance by what? Inches, okay, inches, feet, meters, centimeters, etc. But in the case of the angle, the measurement is called degrees. Now I'm going to introduce the 1 degree, if you like. This type of interpretation was very old. It was done by, if you like, history is done by Babylon. Okay, so that's Babylon. Just piece of history. Okay, that's one. Babylonians. They introduced okay, and this is it. They introduce. If you like, a degree measurement, or the degrees, something like 4,000 years ago. So how they defined it? They just define it in terms of the number of the time that you go around the circle. You see, this is going to be their measurements. So you start, if you start a point here and you just move around a circle. Okay, if you move around the circle, so you start here and just moving around the circle. Okay, so if you start from here and just come back wherever you start with, in that case, we say, oh, you did go around the circle. Okay, go around the circle once. Okay, so this is going to be the one. This is, what do you want? What's the question? I don't know. Would that be something we have to know? No, you don't have to know, but you can know and enjoy that. It's a very great history, rich history of the trigonometry. I usually, when I teach calculus, I'll talk about it quite a lot. But this is just for your information to know that who did it first. Okay, it's a rich history. If you can come talk about the history of trigonometric function, we give you points. Okay, so that is going to be the case. Now, what's the definition? If you go around the circle once, that would represent 360 degrees. Okay, so when you go around one, we say that one complete. There are different ways to define the degrees. This is one. So one complete. Okay, one complete rotation, if you like. One complete rotation of this ray, if you like, that you start and you're moving. This would be represent, if you like, that would be represent 360 degrees. Okay, so this is our meters, if you like, our measures, our units that we're going to talk about it. And so one complete cycle, if you like, around the circle will represent 360 degrees. So if you want to define, so this is going to be the one, so that gives us a chance to define 1 degree. So how are we going to define 1 degree? This is the notation that we're going to use, 1 degree. So the 1 degree would be what? Would be a portion of the circle. What portion? 1 over 360. This is going to be a fraction of what? Of a complete cycle, if you like, complete rotation. Okay, so 1 over 360. If you just measure this one, this would represent 1 degree, and then we can introduce other ones. Okay, that's 1 degree. If you want to have 2 degrees, it's going to be 2 of 1 over 60. 3 degrees, but some of them are popular. If you want to define what's going to be 90 degrees, okay, the 90 degrees would be what? This is a portion of 1 over 360. What portion? 90 portion. So the 90 portion of 360, okay, then you can simplify it. If you simplify these two together, so that gives us a quarter. So a quarter of a complete, okay, of a complete rotation, if you like. A complete rotation is going to be 90 degrees. You know that this is going to be what? This is going to be, this is the portion that we are going to have. So that portion would be over 90 degrees. Okay, an angle with the 90 degrees, or this is going to be the angle. Okay, this is going to be the angle. You know that the name of this angle is right angle. Okay, so the 90 degrees, you must know the name is going to be a right angle. A right angle. Okay, so angle of the 90-degree measurements, we call it right angles. Any question? So we can define any other angles, but we just defining those popular one. So the other one is 180. If you want to define 180 degrees, it's going to be what portion? So it's going to be 180 portion. See, 180 over 360 portion. Because 1 degree was 1 over 360. So if you simplify it, that gives us 1/2. Okay, so it's going to be 1/2 of a complete, 1/2 of a complete, okay, complete rotation, if a cycle. Call it cycle in pre-calculus. Okay, this is going to be the case. So if you want to get this angle, this is going to be the angle in question. Okay, so this is going to be 180 degrees. 180 degrees. Another name we have for it is a straight angle. So it's going to be 180 degrees. Another name for it is a straight angle. Okay, so the straight angle means okay, a straight angle is going to be the one that we talk. So the 90 degrees is going to be a right angle. 180 degrees is going to be a straight angle. So in order to introduce other angles, we just compare it with this 90 and 80, and we are going to give us some names. So we need those names. Any question? So just preliminaries that we need when we go on to get to know these numbers. Okay, now you know that if the angle is going to be less than a 90 degree, we call it acute angle. So let's get those names too. So let's say, so far that's going to be a straight angle. This is going to be right angle. Okay, let's have more. So the more one is going to be, okay, so the other angle that we are going to be interested in are going to be the following. So note that. I'll just give you all the possibilities that we're going to use in this section. Okay, note that if the angle theta is going to be between 0 and 90 degrees, okay, an angle which is less than 90 called, okay, we call it acute angle. So then theta, you must know the name. is going to be an acute angle. Acute angle. Okay, so make sure to remember this one. It's going to be number angle between 0, 0 and 90 degrees. Okay, so for example, this angle is going to be an acute angle. Okay, so that's acute. If it's going to be between, okay, you have another one. If it's going to be greater than 90, so it's going to be between 90 degree and 180 degree. Okay, if this is going to be the case, we refer to it as a obtuse angle. Okay, then data is going to be an obtuse angle. Okay, that's it. So that would be obtuse angle. Okay, so that's going to be bigger than 90. So this is it. This is the 91. So it's kind of, this is going to be the angle. Okay. So this is, that's it. Start from here, the initial one. If you like, you don't have to, but you can do this direction. Okay, that would be the obtuse angle that we're going to be interested in. Any question? So that's one. This and next one, this definition, it would be used quite a lot. If the sum of two angles are going to be 90. So if let's say angle alpha plus angle beta, if the sum of two angles are going to be 90 degrees, we say that these angles are complement of each other, complementary angles. You must know the name because you have it in your problems, the first assignment that you have. So if alpha plus beta is 90 degrees, then, okay, if this is going to be the case, then alpha and beta, those angles, alpha and beta are going to be, are complementary angle. Okay, this is it. These are going to be complementary. Okay, complementary angles. So complementary angles, if the sum is going to be 90 degrees, the sum is going to be 90 degrees, you get the complementary one. You see, look at this one, and this is the 90 degree. So if you get a line here, you see this is one angle. Okay, this is going to be an alpha if you like, and this part is going to be your beta. As you can see, if you add them together, you get the total one, which is a 90 degrees. So one of them is the complement of the other one, if you like. So for example, if one of them is 30 degrees, the complement of the 30 degrees would be 60 degrees, because the 30 and 60 would be 90. Okay, if one of them is 20 degrees, the complement of the 20 degrees would be 70 degrees, because 20 and 70 would be 90. Okay, any question? And the last one that we are going to be interested in, this is going to use most of the time, so the complementary one, if the sum is 90 degrees. We have another one if the sum is 180. So if alpha plus beta is going to be equal to the 180. Okay, in this case, we say they are supplementary. So then alpha and beta are going to be a supplementary angle. Okay, that's it. It's going to be supplementary angles. Okay, if you put them together this time, you must get the a straight angle if you like. So this is going to be a straight angle. You divide it into parts. If you like, this part is going to be you see, this is going to be one of your angles. This is going to be the alpha, if you like, And this part over here is going to be beta. So as you can see, if you add them together, alpha plus beta give you the total, okay, half plane, we call it half plane angle. Okay, any question? So you have, a couple of problems in this case. Your first problem when you want to do your assignment is going to be of this type. Okay, they ask for it. They ask find. You can pick one of them for those 10 problems that they talk about it. They ask find the complement. Okay, find the complement of each angle. Complement of each angle. Remember, the complement means the total must be 90. Okay, so the first one is 30 degrees. You want to find the complement. Okay, different way to do it is 60 degrees. But if you want to write it down in symbolic form, you see this is it. So, you get the alpha is one of them. The other one is 30 degrees. So the sum must be 90 degrees. So you solve for alpha, so your alpha would be 60 degrees. You see, so the complement of, of a 30 degrees would be 60 degrees. Not a big deal. Any question? Another one, if one of them is going to be 15 degrees, you want to find the complement. Okay, so alpha plus 15 degrees must be equal to the 90 degrees. So you subtract it, so the alpha would be 75 degrees. Okay, so the 15 degree and the 75 degrees are going to be a complement of each other. Okay, any question? So this is for the complement. Give me one for the supplement. So example, you may be asked find the supplement. Okay, find the supplement. The supplement of each angle. Okay, the supplement, just remember, the total must be 180 degrees in this case. Okay, so if the angle is, for example, something like 35 degrees, so you have to add something to the 35 to get to the 180 degrees. So the solution is going to be, okay, so you can give us the number right away, or the solution is you want the alpha plus 35 degrees to be equal to the 180 degrees. So you subtract 35 out of 180, so the alpha would be 135 degrees, okay? Or what's that? 145, yes, 45, 145 degrees. So that would be the supplement of the 35. Okay, any question? So these are going to be the one, if you want another one, this is, if one of them is going to be, let's say 120 degrees, if this is going to be the case, and the other one is simply 60 degrees. So the alpha plus 120 degrees is equal to the 180 degrees. So in this case, alpha would be 60 degrees. And then you that. Okay, any question? So this is going to be one version that we are going to have. Okay. Now, when we do the application problems, sometimes these angles would have a smaller portion, if you like. You see, when you have 25 degrees, it may not be 25 degrees. So like the numbers. So in the case of the numbers, when we have a smaller portion, means if you have something which is less than 1, we use decimals to denote it. For example, we say 25.2, 25.25, okay, this type of portion. So in the case of the angles, is going to be the same, especially in application. In application, we are going to have a tool in order, or the tools, in order to identify the small portion of the angles. In order to do the small portion of the angle, we use the measurements of the minutes and the seconds, okay, seconds. Minutes and the seconds is like, if you talk about these degrees to be an hour, if you like, then you can compare it with the minutes and the seconds that you're going to have. And so, for example, if you have a 60 minutes, that give us one degree. And if you have 60 seconds, that give you 1 minute. So especially for the application problems that we have, these portions are very important for us. And we want you to be able to do it for us, okay? When you do the problems in future. In future, of course, you can use your calculator, but not now. You have to do the action for us. Okay, so let's talk about those, give you the remark. In your book, they give you a quick, quick definition now, but they talk about later, but we're going to do it right now. Okay, so this is the place that we talk about it quickly. Okay, are you ready? So give you a remark for a smaller portion. Okay, so I'm going to identify the small portion of their angle. So give a remark, and we introduce that notation right at the beginning, and you get one of them in your one question on your quiz would be related to this small portion. So remind you that the portions part, okay, that's it. So the portions of a degree, okay, a portion of the degree can be measured, because in some discipline, these measurements are very crucial. So you're not going to, leave those portion, okay, aside, if you like. You want to measure it. So the portions of the degree can be measured with minutes. We can measure it with minutes and seconds. And seconds. Now, how are we going to do it? As we talk about it, so we introduce a minute, and we say, oh, 1 minute is what? 1 minute. Okay, this is it. 1 minute is 1/60 and a portion, 1/60, okay, of a degree, of a degree. Okay, and so this is the way we write it down. So the notation is going to be, okay, this is it, 1 for the minute. We use this notation. Okay, so 1 minute is going to be 1/60 of 1 degree, if you like. 1 degree, that's a notation for the degree. Or simply, you know that, or we know that the 60 minutes is going to be equal to the 1 degree. Okay, it's like over and degree, over and minutes, if you like. Any question? Then similarly, 1 second. Okay, similarly, 1 second. 1 second is 1/60. 1/60 of a minute. Okay, so the notation is going to be seconds. So this is going to be notation for the second, double line. 1 second. 1 second is 1/60 of 1 minute. Okay, you know that this is going to be the same as if you multiply another 60, 1/3600 of 1 degree. Okay, so, or simply, if you have 60 seconds, if you have 60 seconds, that 60 seconds is going to be 1 minute. Okay, it's going to be 1 minute, and you know that 336 and 3600 seconds, if you like, and that give you that give you one degree. Okay, so the measurements that we are going to use. So therefore, if we write 12 degree, if you write this notation, 12 degree for the 2 minutes, okay, and 38 seconds. 38 seconds, that would represent, okay, that would represent, and we talk about it in short form, that's going to be 12, okay, followed by the units, 12 degrees for the 2, okay, for the 2 minutes, for the 2 minutes and 38 seconds. Okay, these representations is called, okay, this representations is called, okay, this is called degrees, minutes, and seconds. Okay, DMS. If you see it, this means exactly the one that we talk about it, you know, in short. And they want to write it down in degrees. So if you see this notation, this means you have to break it into parts. Yeah, we are going to tell you what it is. Okay, so you have a couple of quick job to do for us, especially when you want to do the application problems. We have a very good one that we use in calculus. So we need this type of measurements, okay? You know that when you want to locate the cities or points, okay, you usually give you these measurements, if you like, because you know the Earth is going to be a kind of a spherical one, or it's like the ellipsoid. So everything would be measurements with given these type of expressions. So we have a couple of nice problems that we're going to use. So we may have to use operations with these numbers. So the operation is, this would be given to you. This is called in this format, degrees, minutes, and seconds. But you can write this one as a decimal number. Okay, so we can measure or write degrees using decimal numbers, or we can write it down using a DMS format. So you should be able to go from one formula, if you like, to the other one, and you come back, okay? So I'm going to show you how I'm going to do it. Okay, any question? So these are going to be just nitty-gritty of this section, really, that we use in applications. And in future, there are a couple of places that you have to do it. Although you use your calculator to do those type of operations in future, but you have to know the reason, okay? So it's just the beginning. So we'd like you to know it, how we're going to do it. So this is, as I told you, one problem on this one, or two problems really. So this is going to be the first one, example. And one of your assignment is this. They give you one and they ask you to convert it, you see? We want to convert this number. This is a measurement in decimal format, 34.817 thousandths of degrees. Okay, so the measure of the angle is 34 and 817 thousandths of degrees. But we'd like to convert it to the DMC format, you see? Convert it to the, okay, 2 degrees, minutes, degree, minutes, and seconds, if you like, and seconds. Or just they give you this notation, you must know it. Okay, if they say convert it into the DMS form, this is what they are talking about. Okay, are you ready? And so what we do, we write it down in expanded form, like in arithmetic, we break it first. We break it two parts, the whole number part, which is 34. You know that this is and plus 0.817, which is the decimal point. Then we change the decimal point into the, okay. So this is the way we are going to do it. Solution. Let's see. So break it first. This is 34.817. Okay, 17 degrees. We break it into the whole number part, and the decimal part is going to be 34 degrees. Okay, that's whole number part plus 0.817 degrees. That's it. Okay, so we are going to focus on this part. We want to change this one into the kind of, you know, whole number parts to change. So this is going to be degree. So what we do, we change this one into the, we change it into the second, into the minutes. So in order to make this one to the minutes, you make it bigger. You multiply by 60. So this is going to be 34 degrees plus, you get this number, you change it. It's going to be 0.817. So for the degrees, you want to change it to the minutes. You know that each degree is 60 minutes. So multiply by 60, but it's going to be 60 minutes. Okay, so we change the portion from the degrees into the minutes. So this is going to be 34 degrees. You can use your calculator to multiply this number. If you multiply them together, that gives you plus, okay, it's going to be plus 49.02. But this 49.02 is in minutes. Okay, so we get that portion, we get this portion, we multiply by 60 to change it into the minutes. So what we got over here, we have 49.02 minutes. We do the same thing now to the minutes. We write this one into the, okay, this is going to be 34 degrees plus, so change the 49, is going to be 49. It's a 49 minutes. Okay, 49 minutes plus the leftover is going to be 0.0202 minutes. Okay, so you keep the 49, but you change this portion. Now we change it to the seconds, multiply by 60. So this is going to be 34. Okay, that's 34 degrees. Now we get 49 minutes. 49 minutes. Now we multiply by 60 to change it into the seconds. So it's going to be 60, but the units would be changing into the okay, into the seconds. Any question? Now multiply this one. 2 times 6 would be 12. So that gives you 34 degrees so far. This would be 49. Sorry, that is minutes. Okay, degree, minutes, seconds. So this is going to be minutes. Now when you multiply it, the leftover is going to be what? We get 1.2. So that's going to be 1.2 what? 1.2 seconds. And there is a leftover here again. So this is going to be, that's it. And you see, sometimes we ignore that leftover, or sometimes we just skip it. So as you can see, we get to the DMC, so we can write it down as, so that would be 34 minutes, 34 degrees, 49 minutes, and 1.2 seconds. So that would be the final answer. So the given number, which was in decimal form, 34.817 degrees. We change it into the, okay, we change it to the DMS format, if you like. Any question? So you should be able to, you know, on this quiz and the test, you have to show us, you know, the work. Okay, just some calculator will do it right away, but we are not going to use calculator for this one because we want to learn how we are going to do it. So this is one version. Any question? So that was in degrees. We changed it to the DMS. Now how about the other variant? So what are you going to do? If this format is given to you, you have to play back if you like. You see, you multiply the numbers getting bigger and bigger. When you want to get back, you have to make a number smaller. So the one that you multiply, then you have to divide to get those numbers. So we get the other variant question. So nicely done. How about the other way around? So that would be our second problem. Okay, to get these formats, it's, as I told, it's part of, I think, section 1.4 as well, but we do it now. So when we get to that section, we already done. So let's do it the other way around. The other way around is we want to convert this one. I'll say, okay, we want to convert, and let's say converting 74 degrees, okay, 8 minutes, and the 14, okay, 14 seconds. We want to convert it to the decimal degrees. Okay, convert it to the decimal. Okay, decimal degrees. Okay, you have to do it the other way around to get those numbers. Okay, so we keep the 74, and then this is it. Then you have to make these smaller because you have to change everything into the degrees. To change the minute into degrees, you have to divide now. And you want to change this one, you have to divide. So you divide this one by 60, but this part you divide by 3600. Okay, so this is going to be the solution. So for the solution, we have 74 degrees. Okay, 8 minutes and 14 seconds. So we write it down as, this would be 74 degrees plus, this is 8 minutes. So we change it to degree by dividing. So it's going to be 8 over 60. Okay, if you do this one, then you can say degree. Okay, then you can do the other one too. It's a seconds to change it to the degrees, or an hour if you like. So it's going to be divided by 3600. 3600, then your measurement would be degrees. Okay, so the other one, you want to make it into the bigger number, you multiply it. This one, you want to make it to the smaller number, you have to divide. You have to use your calculator to get these. Okay, so that would be 74 degrees. And if you divide, this is what you get. You get a 0.1333. And you do this one, and that gives you 0.0039. Sometimes they give you the instruction how many places are going to run that. Okay, so what I did over here is, okay, now we add them together. So these are going to be all degrees. You see it's going to be degrees. So this is the way I write it down. I run that to the nearest 1000, if you like. Then I add them together. Or you add it first, then run that to the nearest 1000. So that would be 74.137 1.37 degrees. Okay, I think this is it, rounded if you like. Rounded to the nearest, thousand place. Okay, thousands. Because I use only 3 decimal places. Okay, it's not a big deal. So it's going to be 74. That was 74 degrees, 8 minutes, and the 14 seconds that I change it to the decimal one. Okay, so make sure that when you pick those 10 numbers, and these are going to be one of them, but when I post your practice quiz number 1, you will see one of them. So you know that, make sure that you are able to do it for us. Okay, any question? So this is the way we do the partial one. Okay, the partial of the degrees. And sometimes we may have to do operation with these numbers. Okay, especially you may have to add or you may have to subtract. Again, you have option, you can change it to decimals and add, or sometimes you may be asked to do directly. So We are going to show you how we're going to do those operations with these numbers. Okay, any question? So that's one, and this is also interesting. And the interesting part is going to be wanted to perform. That's your second problem. These are all one problem with all these notation. We would like you to perform each as indicated, if you like. As indicated means adding or subtracting. The first one is a kind of addition. Okay, you want to add what is 51 degree. Okay, 29 minutes. And you want to add it to 32 degree and 46 minutes. That's it. You know that in mathematics, we can add two objects of the same kind. Okay, object of the same kind means degrees, degrees, minutes, minutes. Okay, so you know that when we add the digits in the same place value. It's the same thing. Okay, so just do as you do with the addition. We have 51 degrees, 29 minutes. Okay, we do the same thing here. So this is going to be 32 degrees, and this is going to be 46 minutes. I'll add them together. Okay, any question? So we do the same place value. Okay, as usual. What is that? 9 and 6 would be 15. Okay, you carry 1. So that gives you 6, 7. So it's going to be 75 minutes. And over here, 2 and 3, 1 and 2 would be 3. And we get 85 degrees. So the conclusion is 83 degrees, okay, 75 minutes. But you know that this is over 60. So you have to simplify it if you like. So what you do is, this is 75 minutes. So it's over an hour if you like, over a degree. So you can borrow if you like. So you're not done. You're not done. You are going to note that you know that this 75 minutes, 75 minutes is what? Is 60 minutes. 60 minutes plus 15, okay, 15 minutes, but the 60 minutes is one degree. So it's going to be 1 degree and 15 minutes. Okay. So if you go back here, okay, so if you go back here, 83 degree, 75 minutes is going to be, you got 1 here, 1 and 83 would be 84. So that give you 84 degree, but 15 minutes. This is the final answer. Any question? So we add them together. If we, if you get over, because you can have only up to the 60. Okay, you have 75. You have 75, so you carry to the other part. Okay, this is, what is that? It's not 25, it's 15. It's a 75. Okay, we break the 75 into the 60 and 50. 60 and 50. 60 would be 1 degree, 1 degree and 15. Okay, 1 degree and 15 minutes. Okay, so I carry this 1 degree to the 83, so that make it to the 84. Okay, it's going to be 15 because you already break it here. Any question? So that's addition. So when we add, if you go over, okay, if you go over of 70, over of 60, you carry to the other parts. Okay, question? Subtraction is lots of fun. Okay, so how about a subtraction? You know that anytime you subtract, those borrowing is interesting. So that give me 90 degrees. How about 90 degrees minus 73 degrees and 12 minutes? So we're going to do this one. You know that you have to write it down to get the place values. So let's see if we have to do something extra. So what's going to be the solution? Solution is you have the 90 degrees. You have no minutes, so we can say 0 minutes. And over here we have a 73 degrees, but we have 12 minutes. Okay, you want to do this one? You can't do it. We have to borrow. You see 12? This is the 12 minutes, but this is the 0 minutes. So you have to borrow. Now how are we going to borrow now? This is 90 degrees. You borrow one from the 90 degrees. Make this one into the 89. But you borrow 1 degree. You know that 1 degree would be 60 minutes. So you are going to change it into, you see this is it. You borrow one from the 90, make it to the 89. This is going to be 89 degrees. So 89 degrees, but 60 minutes. You see? So we borrow 1 degree out of the 90, make it to the 89. And that 1 degree would be 60 minutes. Okay, now the other one is 73. Okay, 73 degree and 12. Okay, 12 minutes. Now we can do it. Any question? So it's like borrowing of the, when you do the actual subtraction, but you got to be careful because each place value must have its own measurements. Okay, the measurements here is degree. So when you borrow, you borrow 1 degree. 1 degree is 60 minutes. 60 minutes, you change it. Now it's easily done. So that would be, okay, that would be 48 minutes. And you subtract this one, that give you 16 degree. So the final answer is going to be, if you subtract it, that give you 16 degrees and 48 minutes. That is the measurements, the units that we're going to use. There is another unit, which is very important one for calculus, and that's a radian. We talk about it later because we need a little bit more to be able to do it. That's what we done in chapter 3. We usually do it all of them together, but I stay with your book, do it step by step. Okay, so that's measurements. Any question? So make sure you know this type of operation that we did. Okay, these are going to be all new. And the definitions, those expression, especially the complement, when we add them together, we get a 90, supplement 180, and then we get to this, okay, this spot. Okay, I'm going to give a break. This is 7:34. You have 10 minutes as your break, and then we come back and we continue. So what we did really, we just give you the measurements. Now, in order to give the first definition of the trigonometric function, we have to review a little bit of the geometry of the right triangle, okay? So we review right triangle, some famous formula like the Pythagorean identities, then we will be ready to give you the first, okay, definition of the trigonometric function. Okay, any question? So that's 7:35. See you in 10 minutes. Okay, any questions so far? So we give you this measurements of the angle. We call it degrees. And then we introduce how we're going to represent the portion of the degrees using those okay, those idea of the minutes and the seconds. Okay, in order to continue, there are a couple of facts that we are going to use from the right triangle from geometry. Okay, so I'm going to see that one, just make sure you are familiar with. Okay, so we review. We are going to be still in that section 1.1. And this is also part of 1.2, but we do it in this one and we just continue, okay? So reviewing some ideas from geometry that we need. Okay, it's going to be very important. So something about the triangle. Okay, that's it. Triangles. The only thing that we, there are a couple of things, but the only thing that really we want to know is the sum of the measurements of the angles. Okay, so if it is going to be a triangle in general, okay, this is going to be a triangle in general. And if you call the angles to be alpha, and this is going to be beta, or this is going to be gamma, okay, you can call it ABC, it doesn't matter, whenever you feel more comfortable. So the thing that we need to know is the fact that if you add all these three angles together, okay, the result is going to be 180 degrees. Okay, so you can use this one anytime you like. So the sum of the angles in a given triangle is going to be 180 degrees. Okay, so from time to time, one of these angles would be missing. So you know how to find it because the sum of the three angles is 180 degrees. So you have a couple of problems in your book of this type. As we do it automatically, we just remind you. Okay, so they give you this fact that the measures, two angles will be given and they ask for this third one. So the measures of two, okay, measures of two of the angles. Okay, two of the angles of a triangle, okay, of a triangle are 48 degrees and 61. Okay, so one of them is 48 degrees, the other one going to be 61. We want to find the third one. Okay, so find the third one, find the measure. Find the measure of the third angle, of the third, okay, third angle. This is it, no easy problem. I just want to remind you that this is the way we are going to look into it. So you may draw a triangle, and if you identify these two angles, this is going to be 48. It's already given to you. Okay, and this is going to be 61 degrees. This is the unknown. You may call it X, and then you go for the X. So you need an equation. This is it. Sum of the three angles, 48 degrees, 61 degrees, and the X is equal to the 180 degrees. Okay, so you solve the X. You solve for X. If you add these two together, they give 109. Okay, 109 degrees plus X equal to the 180. So you subtract is going to be x equal to the 180 minus 10, okay, 180 minus 109. So the result's going to be 71 degrees. Usually, you know, we just do it right away, okay? But this is just to remind you that the sum of the angles, all the angles, interior angle, we call it, you know, inside the angle, inside a triangle, is going to be 180 degrees. So in order to identify those three angles, you need two angles so that we'll be able to find the other one. Okay, any question? So this is one fact that we are going to use from now on. We just remind you that be aware of that. Ready for the next one? This next one is the most important one. We're going to use this one quite a lot. What is this? You know that is going to be the famous right triangle identity. Okay, we call it a Pythagorean identity. So it's going to be used quite a lot. I have a couple of applications of this one. I want you to know it. Okay, so this is it, the famous Pythagorean identity. Okay, this is it. Pythagorean. Okay, Pythagorean identity. Or identity theorem. Okay, we are going to use it quite a lot, almost in every problem that we are going to have. Okay, that's, if you like, a theorem. You know that if you have a right triangle, see, this is going to be a right triangle. This is going to be the right triangle. Okay, this is the right triangle. You have a right angle. This is going to be your right angle. Okay, these the sides adjacent to the see the terminal sides and the initial sides of this angle, we refer to them as legs. So there's going to be leg and this is leg. Okay, and this one over here, we call it, okay, you know that the famous hypotenuse. Okay, this is it. Okay, so hypotenuse, okay, that's going to be the leg, and this is going to be a right triangle that we are going to have. So we usually use a symbolic form. So if you have a symbolic form, okay, so this is going to be the case that we're going to have. So if you call this side, it doesn't matter, you know, you can use any variables you like, A, B, and this is going to be the C. So what's the Pythagorean identity? The square of the hypotenuse, C squared. C squared is the sum of the square of the legs. Square of the A squared, plus the square of the B, which is B squared. Okay, this is going to be Pythagorean identity. We use it over and over and over in this course. That's a strong tool that we're going to have. Even when you go to the other part of the course, most of our identity is exactly this one, but with different names. And the way we use calculus, you know, or trigonometry in calculus is, or refer to this, you know, refer to this formula. Okay, so the square of the bigger size, if you like, the square of the bigger size, C squared, is equal to the sum of the square of the other ones. In order to get the C, the hypotenuse, okay, this is the opposite of the right angle. So the opposite of the right angle is going to be your hypotenuse over here. Okay, so C squared is A squared plus B squared. Now, in most of the problems that we're going to have, two of these A, B, C, two of these measurements would be given. This is going to be the length, okay, the side length. So two of these measurements would be given to you. You have to find the third one, okay? So we're just going to give you some examples to see how we're going to take care of it and be ready for it for application for the rest of the course. Okay, any question? So remind yourself, make sure you use it properly. So the examples and the way we are going to operate. So there are kind of three possibilities of this type of problems. Example, you have lots of them in your assignment. So what we want to do is we would like you to, it's going to be a triangle when one of the right triangle, when the length of one of the sides are going to be missing. So we'd like you to solve. Okay, solve for the exact value. Okay, exact value for the, or of the, solve for the, sorry, for, so solve for the exact value, okay, of the unknown. Okay, solve for the exact value of the unknown side length in the given right triangle. In the given right triangle. This is your first job. I know every problem that we're going to solve, we're going to find it automatically. So we just want to get it officially. Okay, so when we say exact, means no calculator. Okay, so if you get some radical expression, radical 2, radical 3, you leave it. If you use your calculator, radical 2 would be 1.41. But exact means just write it down as is. Okay, so the first one, this is going to be the first one. This is a right triangle. The numbers is 4, 5, and this is x. Okay, so write the Pythagorean identity. You start with the sides of the square of the bigger one, the hypotenuse. So the sum of the, this is it. You know, you can go with the 5 square or the other one, it doesn't matter. So it's going to be 4 squared plus x squared equal to the 5 squared. So it's going to be 16 plus x squared equal to 25. So for the x squared, so the x squared is 25 minus 16, which is equal to the 9. So x squared equal to the 9. So we take the square root. X is going to be equal to, is not going to be positive negative 3, okay? It's positive because, you know, in general, x is positive negative 3, okay? But it's a length, x is positive. Since x is positive, so x equal to the 3 is going to be the final answer. Any question? So in practice, we write it down right away. You say, oh, 25 minus 16 is 9, so this is 3. We accept that. I just show you, you know, the way we are going to operate. In all our problem, one of them is missing, so we have to find it. We find it quickly. Okay, any question? That's type 1, everything nice. Type 2. Type 2 is this one. This is the right triangle, x is here. X is here, this is going to be 3 and the 7. Again, the square of the legs, x squared, okay, x squared plus 3 squared equal to the 7 squared. Okay, so that gives us x squared, 3 squared 9, okay, plus 9, 4 squared 49. Okay, so you subtract, so x squared is going to be, this is 49 minus 9, which is equal to the 40. So x squared equal to the 40. You want to find the x, remember, we are not going to write positive negative. X equal to just a radical 40. They ask for the exact. This is not the perfect squared. You are not going to use your calculator. Since they ask for the exact, you simplify it if you can. You know that if this is going to be divisible by the square, the perfect square, we can simplify it. 40 is what? Is 4 times 10. Okay, 4 times 10. So the radical 4, you see this is, I just reminded from algebra, is a radical 40, which is going to be radical 4 times 10. So radical 4, it's just for information. Radical 4, radical 10. So the result would be 2 radical 10. So x equal to 2 radical 10. Any question? You don't have to explain these operations, but you have to write it down as x equal to 2 radical 10 because they ask for the exact value, no calculator. Okay, any question? So you know that if this number is divisible by a perfect square, like 4, 9, 25, you break it and then you can pull out that nice part, which is a radical 4. So the answer is 2 radical 10. Any question? So just remind you how we operate in this course. So that was number 2. Number 3. Number 3, you know, various format that they are going to give you this x. Okay, how about this one? You see this is given and you've been told that this is 60. Okay, this is going to be 60. Okay, and you have the other information is that this is x and this is x, and they may tell you that this angle is 45 and the 45. That's why we get the x and the x. Okay, you can have 45, you don't need it. Okay, so this is the case. These are 45. Okay, and we want to find it. So in this case, you just write write your theorem. So the solution is going to be, your theorem is the square of the legs, so it's going to be x squared. Okay, and this one is going to be also x squared. So x squared and x squared is going to be what? Is equal to the 60 squared. Okay, so the sum of the square of the legs. So x squared and x squared would be 2x squared, a little bit of algebra. 60 squared, 6 times 6, 36. So that gives you 3600. Okay, so we divide by 2. So x squared would be what? X squared would be 3600 divided by 2. That give you 1800. Now we have to find the x. So the x is going to be square root of 1800. Remember, you cannot use calculator. You cannot use calculator, okay? So you can simplify it a little bit. Only just leave it, okay? Because this is not going to be perfect square. Okay, to simplify it, you have different way to do it. It's 100 times 18 if you like. You can pull out the 10, or it's a 2 times 900. Okay, this is going to be x is equal to, okay, is going to be 900 times 2. So radical 900 would be 30. Okay, so it's going to be x equal to the 30 radical 2. Okay, now just you will see it just to remind you how we are going to operate. As I told you, you are not going to have it as a separate problems. It's going to be part of the problems that we are going to see in this course in a minute. Okay, any question? So refresh your memory regarding this famous theorem that probably you remember it to get these numbers. Okay, any question? We don't need anything else from the triangles for the time being. In section 1.2, they talk about the similar triangle. We don't need it now, so we are not going to talk about it. So that will help us to be ready to give you the first introduction to the trigonometric function for very special case, but very important case really. That's a crucial one. Any question? So now we know the angles. Okay, we know the angles, we know the measurements. Measurements are going to be degrees and those type of operations. So we are going to introduce you to the function that you live with it for the next 15 weeks. And this is trigonometric functions. But it's very a special version. A special one, the easiest one, and this is the foundation of what we're going to do. Okay, so we are done with the 1.2. We don't need anything from 1.3. I just give you whatever you need. No assignment on 1.2. So that takes us to the 1.3. 1.3, introduction of our tools. Trigonometric function. Okay, trig function we call it. Trigonometric metric functions. Functions. Okay, but we call it a right triangle version. Right. There are different versions, but it's going to be depends on this one. Okay, it's a right triangle version. Triangle version. In your book, they call it right triangle ratios. It's the same thing. Okay, now we are going to introduce, something like 6 functions. Okay, and we are going to the right triangle. So this is it. Suppose, okay, a right triangle is given. A right triangle, just remind you, is given. Okay, this is going to be the right triangle that we have. Okay, this is going to be right triangle. Okay, you identify the the right triangle. So we already talked about it, that this is going to be your hypotenuse. Okay, so we're going to fix a data. We fix an angle. We call this one data. Okay, we call this one data. Okay, angle data. So for this angle that you're going to have, if you like, this leg is going to be opposite of the data. Okay, this is going to be opposite of the data. And this leg over here is going to be adjacent to the data. Okay, it's nice to get these expressions. Okay, so the angle, okay, is the right angle is given to you. So this is going to be called, okay, adjacent side of the data. Adjacent. This is called opposite side. Okay, so it's going to be opposite side of data. Okay, adjacent, opposite, and you know this one. This is just the hypotenuse that we have. Okay, so this is going to be hypo. Okay, so that was the hypotenuse that we have. Okay, hypotenuse. Okay, so let's see how we are going to define those. So if this is going to be the case, now if this is going to be the case, the 6, okay, the 6 trigonometric functions of data of the angle. Data are going to be defined by Okay, this is going to be now. I can do this opposite and the other, or I give you another version so that I give you all of them together. You see, let's take this one into the different format. So it's the same thing, symbolic form. This is the data. Okay, it doesn't matter whether I'm going to call this one A, B, and C. It's the same thing. I give you those in word form and the symbolic form. Now we are going to define you need to define 3 of these angles, the functions. The first function is called sine function. Sine, okay, this is it, sine, S-I-N, sine of data, sine function. Now I'm going to define the sine of the data. You see the sine of the data is going to be, sine of data is going to be the ratio, is going to be the ratio of the opposite side divided by the hypotenuse. Opposite in short, okay, opposite if you like, divided by, okay, this is hypotenuse if you like. Opposite side, I didn't write, I write in short form only. Okay, opposites divided by the hypotenuse. So this is going to be equal to, in this case, you see, the opposite is B and the hypotenuse is C. Any question? So the ratio of the opposite side, the ratio of the length of the opposite side divided by the hypotenuse, this is to call it sine function. Okay, so this is the sine function, sine function. That's the first one. Any question? That's a sine. Okay. Next one, cosine. COS. Cosine of data. Cosine of the data is the ratio of the adjacent side. So the ratio of adjacent side divided by the hypotenuse, hypo, which is equal to adjacent one, we call it A, and that's a C. C. Okay, so the cosine is adjacent one over the hypotenuse. The sine is the opposite over the hypotenuse. Okay, so this is called the cosine function. Cosine function. Sine function, cosine function. Any question? We need one more. Next, tangent, tan function. Tan, T-A-N. Tangent. Okay, the tangent. The tangent function is going to be equal to, the tangent function is going to be opposite over the adjacent. No hypotenuse, if you like, okay? So the tangent is going to be opposite over adjacent. So the opposite in this case, you see the opposite is B, adjacent one is A. So that would be tangent function. Okay, so this is the tangent function. Okay, so 3 functions that we're going to define. Okay, we define the sine function. The sine function is the opposite side divided by the adjacent, divided by the hypotenuse. Okay, so that with the sine function. Cosine function is the adjacent over the hypotenuse. Okay, adjacent. So it's going to be AC cosine. The tangent, opposite over the adjacent one. So that gives you the tangent function. Okay, any question? Now what we are going to do is, We are going to introduce 3 more functions, but those functions going to be reciprocal of each one of these. Reciprocal, okay, you flip this. Okay, this is, you find the sign first, then you flip it. They give you a new function. You flip this on the new function, and then last 3. Okay, usually if you know these 3, you don't have to worry about the other ones. So these are the one, then use reciprocal function. Okay, so the reciprocal function, if you like, just to remember it. Okay, that's it. Reciprocal functions are going to be, you see, the reciprocal of the sine. Okay, we call it cosecant. Okay, it's going to be CSC, cosecant of theta. Most of the time we use those 3, but you may be asked this one. In calculus, we use only all those 3. It's going to be reciprocal of the sine. Reciprocal of the sine, call it cosecant, cosecant. Okay, and if you have the sine, you just use the reciprocal, which is going to be C over B. Okay, so this is going to be a cosecant. Okay, this is cosecant. Cosecant function. Cosecant function. Okay. Now, if you consider reciprocal of the cosine, we call it secant. That's very popular. Secant function. SEC. Secant is the opposite, the reciprocal of the cosine. So you have the cosine, use the reciprocal that give you C over A. Secant. Secant function, very popular for calculus. Of these, the 3 reciprocal, this is the most important one. The other 2, it's used not frequently. And if you consider the reciprocal of the tangent, we call it cotan. Cotan, cotan. Okay, cotangent of the theta. Cotan. Okay, they usually write, COT. I just write all of them. Okay, that's just using your book. Cotan, COT of the theta. Cotan is going to be 1 over tangent, TAN, tan. Okay, we just get the tangent, use the reciprocal, which is going to be A over B. So you don't have to memorize the formula for this. You just find the other one, just find the reciprocal to get this one. So it's a cotan. So it's going to be cotangent, cotangent, cotangent function. So this co means you just do the other way around. Use the reciprocal to get these numbers. This is the easiest and the most important introduction of the trigonometric function. The function is a machine. You drop something into the machine, you get something out. So the one that we drop is this data. 30 degrees. You want to know what's going to be the sine of the 30 degrees, cosine of the 30 degrees, tangent, cotan, secant, etc. They are going to be related to this length that we talk about it, as you can see it over here. So what is going to be your job? This triangle would be given to you. And they ask for all these 6 functions. So you just make sure that everything is ready. And you should have the A, B, C, all of them. One of them is missing all the time. Use Pythagorean identity to find it. And then just using these 3 formulas first. 1, 2, 3 to find the first 3 functions. Then use the reciprocal to get the other ones. This is going to be your job for the next 2 sections, and this is going to be your job in future. This is just, the restriction is we just define this one for the right triangle. But when we get to the other part of the course, we are going to extend it. We define it everywhere. But this is the foundation that we need to know. Okay, so just make sure to write your formulas correctly. These are going to be important. And now we are going to check it. You have to memorize this formula. Okay, it's easy to memorize. Otherwise, you are going to see it. We use it quite a lot to get through these numbers. When the formula getting, more and more and more, I will let you use some of those formulas. But I would like you some of them to, to memorize if you like. But let's do it. Any question? So what's the question? We can just give you one triangle and you have to find it. We give one of them your next quiz. Okay, so there you are. And most of the time, this is only thing you do in calculus for us. Okay, example. Let's do it. That's it. Find the exact value. Find the exact value. Exact means no calculator. Because they can be done by calculator, but no calculator. Find the exact values. Exact values of the six trig functions. Trigonometric. Okay, trigonometric functions of the angle data. Angle data. Okay, so a triangle would be given to you, and then they ask you to do it. This is it. This is the triangle. The information that you have is this is 8 and this is 15. And this is your data. You see, first thing to do, you have to make sure that you have those three sides. 1, 2, 3. It's always one of them is missing. So this is the right triangle. Okay. So your first job is find this part. Okay. You know what to do with the right triangle. So the solution is going to be, I just remind you what is missing. You say, oh, this is it. I want to work with this one because you know the definitions. Just remind you. So your first job is you're going to call this one X and you go and find it. Okay, this is your right triangle. Okay, use the Pythagorean identity, the sum of the square of the legs. Okay, so this is it. We have a 15 squared plus 8 squared equal to the x squared. Remember, sum of the square of the legs is going to be equal to the squares of the hypotenuse. 15 squared, 225, and that gives you 64. It's equal to the x squared. Okay, this would be 289. So that's going to be 289 equal to the x squared. You take the square root. Remember, positive number. So you check your calculator. It's probably 17. Okay, so x is equal to the 17. Any question? Now you can start moving. This is it. This is your angle. And this is your number. 15, 8, and 17. Any question? So make sure to get this one right. Now start writing sine, cosine, tangent first, then use reciprocal to get the other ones. Here you are already. Sine of the data. Sine of the data, opposite over the hypotenuse. Opposite is 15, okay, 15. Hypotenuse 17. Done. Any question? Opposite 15. Hypotenuse 17. 15, 17. You cannot simplify it, that's the end of the problem. Okay, that's sine. Cosine. adjacent 8 over the hypotenuse 17. That's it. Tangent, if you divide this two, that give a tangent. We give you a formula later on, but you can do it. This is a tangent. Is going to be opposite adjacent, 15 over 8. Or if you divide, you see 15, 8. 15, 8 give you the tangent. Okay, flip it, that give you those three. The first one, the reciprocal of the sine is cosecant. Okay, cosecant of theta is 17 over 15. Reciprocal of the cosine is secant. Secant of theta, reciprocal, 17, 8. Reciprocal of a tangent is cotan. Okay, this is it. Cotan of theta is 8 over 15, and you're done. Okay, any question? So it's easily, can be find out to get these numbers. So you have to have everything available on your triangles. You have to have everything available on the triangle, okay, and then you start moving. The sine of the theta of 15, this is it. Opposite hypotenuse 15, 17. Adjacent, that's it. You just need to know this too. We divide the sine by cosine, 15, 8, tangent. Reciprocal, you get the other three. Flip it. This would be 17, 15 cosecant, 17, 8 secant, and 8, 15 cotan, and then you're done. Any question? So that's a type 1, everything nice. Okay, all the numbers are going to be nice. And they ask for the exact, and you don't need a calculator for this one. This is going to be type 1. Okay, let's get this type 2. Sometimes, the number is not going to be nice, and then you are not going to use your calculator. Okay, let's have another one. The other one is, this is how they are going to give you this one. They identify that this is a right triangle. Okay, that's a right triangle. This would be given to you as theta. Okay, this side is radical. This right is 7. And this side is radical 65. 65. Okay, they ask for the 6 trigonometric function. First thing to do, you have to find the missing sides. Okay, so the solution, I'm going to draw this one again to explain it. So this is a right triangle that we have. That's a 7. This is a radical 65. So this is missing. So carefully write your Pythagorean identity. Okay, this is the hypotenuse. Okay, so the sum of the square of the other two, which is going to be x squared plus 7 squared. Okay, 7 squared equal to the radical 65 squared. Okay, make sure you get the right one, because on the other side must be the square of the large side. So this is going to be x squared. Okay, 7 squared would be 49. 49, and this is, if you square radical 65, you lose the radical. Okay, so that gives you 65. So for x, okay, so what you have is going to be your x squared is going to be 65 minus 49. Okay, which is going to be equal to 16. So the x squared is equal to the 16. So your x is equal to 4. Okay, now we can move on. So now I have, this is what I have. This is a right triangle. That's a radical 65. And that would be the 7 and the 4, the legs. Any question? And where was the data? This is your angle. Okay, so get the sine and the cosine, and then you can write the rest right away. Okay, are you ready? The sine. The sine is opposite. Opposite is 7. Hypotenuse. That's it. Opposite of the right triangle. So that give a radical 65. You've been asked exact numbers. You know that. You cannot leave the radical as is. You have to rationalize it. What we do, we multiply the top and the bottom by the radical 65. You have to do it. We don't accept this one. Okay, just remind you that this is the way we do it. You know, you can write it down right away. I just explain it. So you multiply by radical 65 to the top and the radical 65 down the bottom. So radical 65 times radical 65 would be 65. So that gives you 65, and that would be 7 square root of 65. This would be the final answer. Okay, so the sign of the theta, you don't have to explain it, you can do it right away. So it's a 7 square root of 65 and over 65. So that gives you the sign. Any question? So that is going to be the sign. You need the cosine that keep you going. Okay, ready for the cosine. So you have to do these operations because they ask for the exact number. So this means you cannot use your calculator. If you don't use your calculator, you know that you cannot leave an expression with the radical down the denominator in algebra. You have to rationalize it. Okay, now we get the cosine. Cosine is adjacent. So this is your angle. Okay, the adjacent side is 4. Okay, this is going to be 4. And the hypotenuse is a radical 65. And that done, you just multiply the top and the bottom. Quickly, you know that this is going to be 4 radical 65 over 65. Just multiply the top and the bottom by the radical 65. So that gives you the cosine. Question? Now you divide it to get the, to get the other one, or just use the definition. So the tangent is equal to, you see, if you divide, that is 7, 4. 7, 4. And as you know, this is going to be the opposite over the adjacent. So that gives you 7, 4 right away. Okay, so this is the three function that we have. Now we can use the reciprocal quickly to get the other ones. Okay, any question? Reciprocal of the sign, you see this is it. So that gives you cosecant. You better reciprocal this one, because otherwise you have to change it. Okay, this is it. So that gives you radical 65 divided by 7. Okay, this is it. If you use the reciprocal of this part, that gives you secant. Sorry, that's a cosecant of theta, of course. Okay, secant of theta is going to be reciprocal of the cosine, which is going to be radical 65 over 4. So that would be the secant, and the cotan is clear reciprocal of this one. So that gives you cotan of the data, which is equal to the 47. And with that, you see, it's nicely done to get those numbers. Okay, any question? So this is the way you are going to use this idea. Okay, that's your main job. This information will be given to you, then you'll be able quickly to find the numbers. Okay, so that was a kind of exact operation that we are going to know. We are going to have. Okay, for these type of numbers. That's a type 1 problems. Any question? Now, what's going to be the type 2 problems? The type 2 problems is very, very similar, but you see this one, for this one, all these values was nicely given to you, A, B, C, then you'll be able to do it. Sometimes they change this version, okay, instead of giving you these 3 lengths together, they may give you one of these 6 functions, and they ask for the other 5. Okay, so let's check other possibilities to see how we're going to do it. Okay, so that's one version, straightforward. You get one of them in your next test quiz, and this is section 1.3. Those 10 problems that I talk about it, most of them are going to be of this format. So what is going to be a little bit tricky one, if you like, that you're going to find, okay, a little bit more algebra involved. This is type 2 that we usually give you 1. Okay, let's see, what is this one? You see, you are going to be given that, okay, a kind of application types, if you like, right? It's the same thing. Okay, if, you see, if data is the angle, is going to be the angle. Okay, quickly, anything we learn, we are going to apply it. If data is the angle formed, okay, angle formed by the heel, if you like, okay, by the heel and the ground, if you like, a ground as shown. This is a kind of application problem that we have, as shown below. I'm going to show you below, such that the secant of data is given to you. The secant of data is 1.75. Then we'd like to find the sine, if you like. Find sine of data. Some specific one is already given to you. You see, this is what they are talking about. We have the heel and the ground. Okay, this is the shape would be given to you. Okay, so this is going to be the ground, if you like, and this is going to be the heel. So we have a right triangle here. Okay, the angle theta is here. So this is going to be the angle theta. Okay, this is it. So we have the heel, if you like. This is it, the angle formed by the heel here and the ground here. Okay, the ground here. And the only information that you have is the fact that the secant of the data, okay, secant of the data is equal to the 1.75. And you would like to find the sine of the data. Okay, so in order to get this one, you must have, you know that you must have, what is this 1, 2, 3 here? Because if you have this length, you'll be able to find it. Okay, so let's call this one to be A, and this is going to be B, and this is going to be C. And try to use this information to get this, okay, use this information to be able to get the result. Okay, so we can start with the definition of a secant. Okay, the definition of a secant to see if we can find this information. Remember, what's the definition of a secant? Okay, note that we can go with the secant as is, or just make it to the something familiar. So the secant is 1 over cosine. You see, this is it. Secant of theta is equal to the 1 over cosine of the theta. But this number is already given to you, is 1.75. Okay, remember we reciprocal to get the reciprocal of the cosine is going to be secant. Now I have the reciprocal, so if I just flip it, so that give me the cosine of the theta is equal to the 1 over 1.75. Okay, but what is the cosine? Remember the cosine? What's the cosine? Cosine is the opposite adjacent sides. Remember, adjacent divided adjacent over the hypotenuse. So it's going to be adjacent, which is A, and this is going to be C. Okay, so the cosine of theta is 1 over 1.75, but the cosine is A over C. Compare them together. If you compare them together, your A is equal to 1, your C is equal to 1.75. So you see, in the previous problems, ABC was given to you directly. But in this type of problems, they give you one of these angles, okay, one of these functions. In this case, the secant was given to you. Secant is 1 over cosine. So 1 over cosine is 1.75. So 1 over cosine is 1.75, okay? So we use the reciprocal. We use the reciprocal to get the cosine, which is 1 over 1.75. But what is the cosine? Cosine is adjacent side over the hypotenuse. Now compare them together. A is equal to 1, C is equal to the 1.75. And that keep us, keep us going. To be able to find the, to know it. No, you just keep the numbers as is. This is decimal number. Okay? And this is it. We talk about calculator. Which is the calculator? No, in this problem, they didn't ask for any specific one. It's already given to you, the numbers. You see the numbers, they give you 1.75. Okay? They asked that, somebody asked if we couldn't use calculator. You cannot use calculator for this type of problem, you see? They asked for the exact value. This problem is different. Sometimes, okay, sometimes this is another version of our problem because the secant is, there are different ways to find the sine, but this is going to be one version. Any question? Of course, we are not done. So what we have so far now, remember we are looking for the sine. So in order to get the sine, so let's get
to find B.
Very good, excellent. We have to find the B.
B.
Yes, you are right. So let's write it down again. So that's going to be the theta. So the A is 1. Okay, the C is 1.75. Yes, you are right. You have to find the B. Because you know that the sine is what? The sine is the opposite side over the adjacent. So use the Pythagorean identity, remember? So it's going to be B squared plus 1 squared equal to the 1.75 squared. Okay, 1.57 squared. So it's going to be B squared plus 1 use calculator to get this, 1.75 squared. If you square it, what's the number? I think it's a 3 point, you have to use calculator, of course, for this one. 625. Okay, so the b squared is equal to 3.0625 minus 1, which is going to be 2.0625. So the b is going to be equal to the square root of 2.0625 with your calculator, because you don't have, they didn't ask for this application problem. In application problem, you are not going for the exact. Okay, so if you do it, your b would be 1.44. So 1.44 is going to be the b. So now we can find the sign. I just want to give you quickly a kind of application, or the two types of the problems that we have so far. So that's your data now. Okay, there you are. This is 1.75. Okay, and this is 1.44, and this is 1. Now we are ready to give you, okay, we are ready to give you the sign.
Fine.
Okay, so what is going to be the sign? That's it.
1.44.
The sign is going to be the opposite, 1.44 over 1.75. Okay, then you have to use your calculator to get this number. So the sign of the theta is going to be 0.82. So that gives you the final answer. Okay, to get these numbers. So it's a kind of interesting problem that one of the function is given to you. You want to find the other ones. You're going to have various ways to do this one, but that's a nice one so far. We have some identity in future that we can use, but we don't use that type of identity. That's the quickest way to do it. And this is the type that, if they calculus, we are ready for it to get these type of numbers. Okay, any question? So we are going to do more, of course, when we when we keep going, but you have to have a little bit more resources to be able to give you more problems. Okay, question? So get to know it, these formulas for the right triangle, that we are going to use it quite a lot. Now, what we are going to do is, of course, in these problems, we just use this ratio to get the sine, cosine. There are some special angles. There are some special angles that we can find their 6 trigonometric function, the exact value, if you like. And there are some that is not going to be possible for us. Now, you see, I just explained one of them for you. These are going to be the one. The proof are very nice. Okay, very nice. You just do one of them so that you can see it. But otherwise, you have to memorize it. The special angles are going to be 30 degrees, 45 degrees, and the 60 degrees. These three are going to be used quite a lot. Okay, and I will add the 0 and the 90 together. So if you can, I just show one of them, but you can use it in general. And for the rest, you don't have to memorize it. When we get to the other chapters, we have something we call it, when we get to unit circuit version of the trigonometric function, we give you a piece of paper, 1 page, and then you have all the famous, function around. But I explained just, historically, how we're going to get these, one of them. You don't have to memorize it. Okay, the proof, but you better know these three famous one. Okay, so let me just explain one of them. Any question? So that's your main job in this chapter. The rest of this chapter is just summarizing this one. At this part, your book, they talk about those measurements that I talk about it, minutes, degrees, we have it. So this is part of 1.4. Just quickly give you one of these ideas and the table. We want to check some famous functions, famous angles. So what is going to be trigonometric function? Trigonometric metric functions. There are some other way to do this, easier one. We do it in future, but we don't need it really. What is trigonometric functions of special angles? A special one, a special angles. The angles that in your book, they call it a special are 30 degrees. Okay, 60 degrees and 45. Just do one of them quickly, we don't have to know it, but we have to know the result. Okay, so this is it. So I just give you one as an example. So the question is going to be, this is the one that I'm going to answer. Question. We want to find the sixth trigonometric function. Find the six trig functions. The six, find the exact, of course, find the, I have to tell you the exact. Find the exact, okay, exact values of the six famous six trig functions. Trigonometric metric functions. Okay, functions of the angle 30 degrees. It's something that we have to use from algebra. I just show you from geometry, sorry, to get these numbers. Okay, the way we do it, we have to do it by using the right triangle version. Okay, so the solution is going to be solution. So you just consider this triangle. So that's going to be right triangle that we have. Okay, in this case, this is the right triangle. Okay, suppose that the angle in question is this one. So suppose this is 30 degrees. You know that if it's going to be 30 degrees, so this is going to be what? This is going to be 60 degrees. Okay, so that's going to be 60 degrees. Okay, in order to find it, we have to know what's going to be the hypothesis or the opposite these sides. Okay, so what we are going to do is we are going to, you have this one, we are going to make a copy of this angle triangle again, and we put the copy here, you see. We put the similar copy here, exactly the same one. Okay, so it's the same copy. So this means this is also 30 degrees. Okay, and this is going to be 60 degrees. 60 degrees. Okay, so what we have is, so this means if this length is going to be x, this is also x. Okay, now this triangle, we get a 60, and we get the 60 here. You see, we get a 60, 60, and the total angle over here, this is going to be also 60. Okay, so it's a, what do you call it? It's a equilateral triangles. It's going to be triangle whose three angles are the same. You know that in geometry, these lengths are going to be the same, you see. This is going to be equilateral. So this means they are must be equal to each other. So this is x and x. If you put them together, that give you 2x. Okay, so this side is going to be 2x, and this side is going to be 2x. Okay, so that's something from geometry, and that the side which is opposite to the 30 degrees angle is, if you like, half of the hypotenuse, if you like. So we just use this observation and we bring down our triangles again. Any question? It's just a trick from geometry, just theorem from geometry. This is a 30 degrees again. Okay, 30 degrees. So what we have now is, this is it. So we know that this is going to be x, and this is going to be the 2x. Okay. So now we are ready to give you the sign, because we have the, okay, and we can define the sign for you because we have the opposite, okay, we have the opposite sides, if you like. You see, if you take this one, x is going to be 2x, even we can find this one. Okay, now how are we going to find it? Remember, if you use the particular identity to get this number. So suppose this is a. If I want to find it, the sum of the squares is going to be a squared, okay, plus x squared, and this must be equal to the 2x squared. 2x squared. Okay, so from that part of the geometry, I proved that if I take this one x, this must be 2x. Now that will enable me to find the a, this part here. So a little bit of algebra, this is a squared plus x squared, and this is going to be 4x squared. I want to solve for a, so that's going to be a squared equal to the 4x squared minus x squared, which is a 3x squared. So a squared would be 3x squared. So if you want to find the a, you take the square root. A would be what? Would be the square root of the 3x squared. You can pull out the x, so that gives you x radical 3. You see? It's all algebra. Nice, if you like, proofs. So what we have, remember what we are looking for. So let's go back. This is a triangle. Remember, that's a 30 degrees. So if you call this one x, this would be 2x. And this would be x radical 3. You can find the 6th trigonometric function now. You can call x1 if you like. That's a 1, 2 radical 3, or just x. Okay, so that's a little bit of trick. That's history. That the way, you know, they create the sign of the sign of the 30 degrees. So now we are ready for it, you see? The sign of the 30 degrees. The sign of the 30 degrees is what? Is opposite side, x, hypotenuse, 2x. Simplify the x. If you simplify the x's, you get them 1/2. You see? Because you can drop the x. What's going to be the cosine of the 30 degrees? Cosine of the 30 degrees. The cosine is adjacent side. X radical 3 over x. Over 2x. You simplify the x's, that give a radical 3 over 2. So that's the sine and the cosine. Tangent, you divide. Tangent. Okay, the tangent was opposite side adjacent one. Or if you divide, that give you 1 over radical 3. Okay, if you like, it's going to be x over, I write it down for you. It's going to be x over x radical 3 That give you 1 over radical 3. You rationalize it, that give you radical 3 over 3. You see? And that used to, you can use the reciprocal to get the other one. Okay? Reciprocal for the other one, quickly, reciprocal of this one is cosecant. Cosecant of the 30 degrees would be 2, because use reciprocal of this one. Reciprocal of this one would be secant. Secant of the 30 degrees. You turn it over, and that give you 2 over radical 3. And you simplify it. You multiply by radical 3, 2 radical 3 over 3. You don't have to memorize this, because you just use the reciprocal to find it. And the cotan of 30 degrees, okay, the cotan of 30 degrees would be radical 3. So that's a kind of proof of how we're going to find okay, the exact value of the 6 of the trigonometric function, okay, of the 30 degrees. You can do the 60 and the 45 using a similar method if you like. But I just give you this one so that you can see it. But I'm going to write the final answer as a chart, and you better memorize it. Okay, we give you this chart later on, but they are very popular. Try to memorize it if you want to calculus, because in calculus we're mostly dealing with these 3 angles, 30, 60, and 45. Okay, because over there they let you use calculator. But these 3 are going to be popular. You don't need any calculator. For the others, they let you use calculator. We give you all the information you need. But in this course, these 3 are going to be popular. Okay, so I write it down in a table so that you can keep it. Try to memorize it. Even if you cannot memorize it, you can bring it to the test. Okay, later on we let you bring all of them to the test. But just for information. Any question? So basically, I prove it from nothing, if you like. But our suggestion is this table. We are going to use it quite a lot. So not bad. Try to memorize it. Just 3 function would be fine. Okay, this is it. This is the angle, which is going to be theta. So I like the sine of the theta. Okay, I like the cosine. So that's a sine, theta, if you like. That's going to be theta. I like the tan. That would be enough, really. Because you can use you can use the reciprocal to get all of them. So just know these. If you need it, you can use the reciprocal to get the others. And so if you have a 30 degrees, we just proved it, that the sine is 1/2, cosine is a radical 3/2, and the tangent is radical 3/3. That is going to be the tangent, okay? And this is it. Cotangent is easy. Let's have the cotangent too, but you don't need it really. Use the reciprocal to get it for the other ones. You don't need it. Okay, so this is going to be the case. For the 45 degrees, very popular. The 45, this is going to be radical 2/2. A radical 2/2, they are the same. And the tangent is 1. Okay, tangent is 1. And for the 60 degrees, it's the other way around. This, we call it co-function, we talk about later. So the sine is the same as the cosine, radical 3/2 of the 30 degrees. And this is going to be 1/2. And this is going to be radical 3. You see, most of the problems in calculus would related to these 3. So it's nice to memorize it. Okay, and we use it in exact form for various purposes that we're going to have in this course. So it's not bad. okay, to memorize this, to be able to do it. Now, these are going to be the exact. So what are going to do for the rest in this course? We let you use your calculator, okay? So you need an easy calculator, whatever you have. Okay, that's the cheapest one that we have. Okay, you need it for the test, for the application problems. You see, if I ask you what is going to be the sine of the 25 degrees, you can do this type of operation, and those tables not going to be giving you these numbers. Okay, so make sure that you know whatever calculator you have. Make sure you have this sine, cosine. Okay, this is the one that I post on the syllabus. Okay, we don't need fancy one really, but make sure you have. You see, this is the sine, cosine, tangent to get these numbers. So this is my calculator. I turn it on. Okay, this is it. You see, when this is going to be, you will see this is called degree. You can see it, degree, and you can change it. We don't need to change it for the time being. Just make sure you are in degree. Okay, these measurements. So for example, if you want to find the sine, so you click on the sine, you see SIN appear here, the sine. So if you want to find the sine of the 30 degrees, you see 30 degree, it's already in degree. I close this parenthesis and I click, that give me 0.5. You see, you have it 0.5, which is a 1/2 year. Okay, and so for example, if you want to find the tangent of 45, okay, you click on the tan, that's 10. So if you want to find the tan of 45, okay, you click, and that give you 1. The tangent of 45 is equal to the 1. Okay, so of course, you know, if you want to find the, for example, if you want to find the cosine of, you see this is the cosine of 45, cosine of the 45, so that give you 0.7 something. You see, 0.70, it's not exact, okay, it's not exact, but if your problem is going to be a kind of application type, we talk about the miles, dollars, etc. So of course you're using this type of, you know, you're using decimals most of the time. So make sure to get to know your calculator. You may, should you know, you are going to be able to find it for us. Okay, so I just remind you that you have to, and you know it. These are going to be the exact, the popular one, but you have some example in your book that they ask you. So I write it down so that you practice. Okay, you practice to find. Okay, we are going to instruction. Use a calculator if you like. Use a calculator to find the following. Okay, to find the following, and they may give you the instruction. The instruction is going to be, in this case, they ask you to round. Okay, round your answer. Okay, you're going to round your answer to 4. Okay, 4 decimal places. 4 decimal places. Okay, because when you use your calculator, you are going to have quite a lot. Okay, just to show you a couple of them and then be done. You see, suppose you want to find the cosine of 22 degrees. Get practice with your calculator. Even your cell phone will give you these numbers, but on the test, you cannot use your cell phone. Okay, so this is it. This is the cosine. Okay, the cosine of 22, and that's it. 0.9271. Okay, so this is going to be equal to, okay, point. I have the 9271. Since they asked for the 4 decimal places, I go with the 5 first, then I run that. Okay, so this is going to be the 4th place. The number is 8 bigger than 5. So I round it into the 0.9272. This is going to be the final answer. Okay, this is the way you do it. They ask up to the 4 decimal places. So you pick five decimal places, and then you round it for us. Okay, just give me one more. So they ask for the tangent of 81 degree. Okay, tangent of 81, and this is it. You click on the tan, that give you 81. This is 81. Okay, this is the number 6 point. So that's going to be 6.3137. Okay, 7 and 5. So again, 4 decimal places. So you know that when it's a 5 and bigger, you add 1. 3138 is going to be the final answer. Okay, so just make sure that you know you are ready to find this number for us. Okay, now we are ready to get more applications. That this is going to be what we are going to do in that section 1.5, and we finish this chapter quickly. That's it for tonight. Any question? So you should be able to do the problems of the section 1.1. There is nothing on 1.2. So you go to the 1.1, 1.3, 1.4. Okay, the only one that we need to talk about it, it's not a new formula. Just to know it is 1.5. Okay, so far we are going to be able to 1.1, 1.3, and 1.4. Okay, wait for 1.5. Then we finish this chapter. Okay, so that was the right triangle version. Okay, so the recording would be posted in 1 hour. Okay, the Zoom sometimes takes a little bit time to deliver it, but I will post it right away tonight. Okay, so the next step is to see this is a right triangle version. If you are going to be in right triangle, you can only use the angles between 0 and 180, but would like to be able to use any angle. Would like to change the domain of this function into the all real numbers. So that's why we bring more tools to be able to do it. But the foundation is going to be unchanged, the one that we covered, tonight. Okay, so we take to chapter 2, another version of this, and next week. Okay, any question? So during the week, I will post your practice quiz number 1, because next week we go over a little bit more, and then we practice for the quiz so that you get an idea of what's going to be on the coming quiz. If you want to get it, very much in advance and start working, so you will have all the information. Any question? So any question, you can email me, okay, and we can set up office hour if you need. And just keep up. This course is not difficult, but you get quite a lot, okay? But the foundation is going to be the same. So just make sure that you keep up with the pace that we are going to have, okay? And everything will be fine. Okay, any question? So have a good
I have
evening
a
and
question
nice.
on
Yes,
how you grade the problems.
yes.
So if say we did like all the work right, but the end answer we might have just done like a dumb little mistake and it's not the exact answer, do we still get partial credit?
Yes, I don't care about the final answer. I give you 2 out of 10 for the final answer. But your operation and your writing is the one that we care about. Okay,
Okay,
that's
thank
why.
you.
Yeah, because it's not a multiple choice question. Okay, I never give you a multiple choice question. So, I read through it, yeah. Yeah, I mean, the final answer, you get 2 points. But the way you arrive at the answer, okay, it's important for us, the way we do it, okay?
Okay,
That's going to be
perfect.
fun.
Thank you.
Okay, so keep up, just quickly take care of, these problems, any difficulty, anything, just let me know quickly. Okay, nice meeting you and see you next week. Any question, any concern, email me. Okay, have a good night. Bye bye.
Bye bye.
Bye
Bye.
Thank you.
bye. Bye.
Thank you.
Bye. Good to see you.